Considering the large freedom when designing a ship hull, the traditional approach cannot provide sufficient information about the design space. Manually generating a fair hull shape that meets the constraints and evaluating the performance for the operating profile takes just too much time. We have combined the most advanced technologies available today and used them on huge parallel computers to evaluate the design space with many thousand different design variations.
If you ask a highly qualified naval architect to model and vary a hull form on your behalf, he or she would probably need a few hours with a standard computer-aided design tool. Now, this naturally does not allow to investigate hundreds or even thousands of variants. Having realized that, back in the 1990s we said we would research and develop tools and mathematics to counterbalance that situation so that a naval architect could basically at his fingertips create a hull geometry and vary it. That is the backbone of geometric modeling, as it's called now, parametric modeling for simulation-driven design, and it's being realized within the Friendship framework, and it's used by FutureShip in its processes to do hydrodynamic optimization of hull forms.
While these are the technical tools assembled, it is obvious that such a complex optimization cannot be performed without extremely skilled and experienced people driving it. That means, for instance, that building up the sophisticated parametric model for the hull geometry representation, setting up the automatic optimization and running it on a high-performance cluster, and very important, carefully reviewing and appraising all results in the end by real experts with naval architect eyes.
Our new optimization procedure proved successful in many projects. Consequently, we increased resources. Today, an interdisciplinary team of 40 experts work in fluid dynamic optimization. We operate several high-performance computing clusters, the latest one featuring over 6,000 CPU cores, delivering a peak performance of 58 teraflops. This enables us to evaluate more than 100 designs in parallel at different operation conditions while keeping response times low.
With these resources, we design 20,000 hull forms and evaluate the most promising one for the operational profile of the vessel. But we don't just analyze 20,000 designs for the propulsion energy needed. We conduct these analyses for all the relevant operation conditions that have been defined together with the customer.
Container shipping, as well as the container ship building, is still a people business, and GL, as the leading classification societies for these ship types, know all the kind of constraint of building and classifying this kind of vessels.
The technology that we're using is new to many of our clients. Therefore, we check the final results by towing tank testing. Looking back, we have applied successfully this technique to many different optimization projects, ranging from large container carriers, bulkers, tankers, and even for racing yachts. Even ships that could be considered optimal by traditional means could be improved further. We could reduce the fuel bill of our clients by many million US$ each year.
Other than technology we offer throughout the optimization process, one of the assets which is very important and should not be underestimated is our customer participation in the project. This will allow the customer to have a better understanding on the choice they have made, as well as they can select a ship that will fit into their operation profile. Customers also welcome the opportunities to participate in the projects where they can learn the new technologies and improve their knowledge. All in all, we want to build a ship that is more fuel efficient and beneficial to the industry.